Let's take a look at this first example A. First of all, we want to determine if the function is one-to-one. Remember, if we're looking at whether or not something's one-to-one, I'm looking at the y values and seeing if they repeat, because I want to pass the horizontal line test, which has to do with y values. So if I look at the y values here for this function, they do not repeat. So yes, the function is one-to-one. And we'll write that out in Word. Yes is 1-to-1. And if you wanted to give a reasoning, you'd say that the y's do not repeat. So it's going to pass the horizontal line test. Which means that if it's going to be one-to-one and it passes the horizontal line test, y's are not repeating, yes, you can find the inverse. So let's find the inverse. So yes, it has an inverse. What do we call inverses? Well, this is our function f. We're going to put a little -1 to indicate that whatever I'm going to write is going to be the formula for the inverse. So if our original function is a bunch of points, our inverse has to be a bunch of points. How do we find the inverse? We do what we were saying up top, which is we're going to swap our x's and y's. So if the original function had 5, 12, the inverse is going to have the reverse. It's going to have 12, 5. And it's also going to have, going to the next point, 22, 5. And swapping the next one, 32, 5. And one more, it's 42, 20. And that's it. And notice, because we made sure that the y's didn't repeat in the original function, notice that now our inverses do not have repeating x's, which means it is a function. That was the goal, was to make sure that you end up with an inverse that's a function. If your inverse isn't a function, it's not going to be valid and you just throw it out anyways. You won't be able to use it. Let's take a look at this next example B. In problem B, we're asked if this is one-to-one, so we'd start by looking at the y values to see if it's going to pass the horizontal line test. And what you'd notice pretty quickly is that we have two y values that are repeating. So the y's are repeating, which means you're going to fail the horizontal line test, which means that you do have something that is not one-to-one, which means that this is going to be not having an inverse. So there is going to be no inverse because it's not one-to-one and it fails the horizontal line test. However, if you didn't catch this right away, it would still be okay because you would try to find your inverse. And how do you do that? Again, you would swap your x's and your y's. You'd go point by point. So the first point would turn into 10, 0. The next one would turn into 20, 1. The next one would turn into 10, 2. And the last one would turn into 40, 3. And you'd zoom out, look at what you think is your inverse, and you'd say, uh-oh, there's a huge issue here. Because what you'd notice is you've got 2 points with x values repeating. And you'd remember from way back when that if you have x's repeating, it is not a function because it's not passing the vertical line test. And if it's not a function, that means it's not a valid inverse. You cannot use it. So you'd say, oops, I was wrong. It isn't one-to-one. It's not a function if we try to find the inverse. So this is not one-to-one. It has no inverse, and we're done. So you can either catch it using the horizontal line test by looking at the y values, or you can just kind of try to find the inverse and see what happens. It does fall apart on you because it's not a function. It doesn't pass the vertical line test because what you notice is you do end up with repeating x values. Kind of two different ways to catch the same issue. Now, we've seen this before, but we just want to kind of emphasize this again, is talking about composition of functions and how do you know if two functions are inverses? Well, one way